In the expanse of space, where quiet is king and measures are expressed in billions of kilometers, two solitary wanderers make their way, Voyager 1 and Voyager 2. These two ships that were sent into space during the late 1970s were designed to function for but a few years, and yet here they remain almost 5 decades later, still bearing Earth's messages, still speaking softly into the infinite black. Last year, NASA announced that it had stirred renewed world interest. Voyager 1, the farthest human-made object in the cosmos, had resumed sending useful information after being silent for months of sending nothing but scrambled signals. It was a reminder that even at the boundary of interstellar space, the voice of humanity still remains. And yet, as mind-blowing as that is, what Voyager 2 learned on its own trajectory into the unknown can be even more mind-boggling. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. We used to believe that we knew the limits of our solar system for decades. Beyond the planets, beyond the asteroid belt, and through the cold Kuiper belt, we pictured only a gradual decline into the emptiness, until at last the Oort cloud formed the edge of the sun's dominion. But Voyager 2 broke that presumption. As it passed across the outer edge of the heliosphere, the solar wind's protective bubble, it measured something no one had anticipated. Plasma levels plummeted, particles changed, and magnetic fields contorted in ways that were unexpected. It was like the ship had flown through a secret wall, an invisible barrier, or perhaps something even more sinister, something observing us from the other side. Scientists were left speechless, their solar system models in shambles. The readings indicated that we might not be floating aimlessly in interstellar space after all, but rather drifting in a vast cosmic bubble. What that does to our picture of the universe remains to be argued, but this much is clear: Voyager's findings have revolutionized everything. In order to find out how we arrived here, let's turn back to the start, when the Voyagers were nothing more than a visionary project at NASA. We begin in 1977, a time when the human species was still just learning to spread its technological wings beyond the immediate neighborhood of our planet. 2 weeks later, on September 5, the second spacecraft, Voyager 1, followed its twin, Voyager 2, which had been launched on August 20 of that year. Identical in design but projected to fly slightly different paths, Voyager 1 would take a quicker, more direct path by Jupiter and Saturn, while Voyager 2 would fly a more sedate, more adventurous course through all 4 of the far planets. Their launch schedule was no accident. Astronomers had noticed that there was a once-in-176 years alignment of the planets which would take place. The 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, were in a configuration that allowed one spacecraft to utilize their gravity as a slingshot to bounce itself from one to the next on a cosmic, grand tour. It was an opportunity too good to pass up, and NASA took it. Each Voyager was equipped with an arsenal of advanced instruments, engineered to record every possible detail of the outer planets. Cameras would snap pictures of their moons, rings, and turbulent atmospheres. Spectrometers would record temperatures, atmospheric gases, and chemical mixtures. Magnetometers would chart the unseen magnetic fields that enveloped these giants. Plasma detectors would detect charged particles' motions. And all of it would be relayed back to Earth via the Deep Space Network, a worldwide network of 3 huge antennas in California, Spain, and Australia, spread 120 degrees apart so that at all times, one of them would have been able to hear the weak whisper of the Voyagers across the universe. Jupiter was the first port of call. Prior to the arrival of the Voyagers, Jupiter was a fairly straightforward world, a gigantic ball of gas, some brightly colored belts, and a few moons. What the spacecraft uncovered dispelled that notion forever. Voyager 1 photographed lightning storms in Jupiter's atmosphere, the first time lightning had ever been seen on another planet. It found that Jupiter sported a thin ring system, establishing that Saturn was not alone in this feature. It also found the magnetic field of the planet to be unimaginably powerful, generating radiation belts so strong they would incinerate any unshielded electronics. But the most shocking discovery was made on one of Jupiter's moons, Io. Scientists were amazed as Voyager snapped pictures of hot, active volcanoes on its surface erupting. It was the first proof of volcanic activity outside our planet, and it meant that other worlds might be a good deal more active than anyone had thought. Next was Saturn. Voyager 1's close flyby in 1980 revealed Saturn's stunning rings in stunning detail, with intricate structures, charged dust spokes, and even a new faint ring. The spacecraft also learned of an extraordinary, hexagonal-shaped storm churning on Saturn's north pole, a flawless geometric hurricane thousands of kilometers in diameter. Nobody had ever witnessed anything like it, and scientists are still trying to figure out why it holds its shape 2 decades later. Saturn's moons were equally astounding. The giant crater on Mimas made it resemble the Death Star from Star Wars. Enceladus indicated resurfacing and possible internal heat. Iapetus surprised scientists with its 2-color appearance, half shining like snow, half as black as coal. While Voyager 1's mission might as well have ended with Saturn, its twin continued on. Voyager 2 became the only craft to visit Uranus and Neptune. At Uranus, in 1986, it found 11 new moons, weak rings, and one of the most bizarre magnetic fields ever seen, nearly 60 degrees off-axis and asymmetrical, as if the whole planet's magnetosphere had been distorted and pulled. One of the moons of Uranus, Miranda, showed giant cliffs 20 kilometers tall and patchwork topography that seemed as if the moon had broken apart and been reformed. 3 years after that, in 1989, Voyager 2 arrived at Neptune, the farthest planet from our solar system. What it encountered was remarkable. Neptune was no peaceful, icy world that many had envisioned, but a stormy place with the solar system's fastest winds, at more than 2,000 kilometers per hour. Voyager 2 found the Great Dark Spot, a storm that measured as big as Earth, and a white cloud called Scooter that shot across the atmosphere. It also uncovered Neptune's moon Triton, which proved to be active geologically even though it was cold in temperature. Nitrogen geysers were observed shooting out of its surface, something no one expected. Following these planetary encounters, both spacecraft began a new journey, interstellar mission. Voyager 1 entered interstellar space in 2012, and Voyager 2 followed in 2018. These transitions were not symbolic. As the probes crossed the heliopause, the boundary at which the solar wind yields to the interstellar medium, they delivered the first direct measurements of what's outside our solar bubble. Voyager 2, which still had an operational plasma instrument, measured an abrupt change. Solar plasma disappeared and was replaced by denser, colder interstellar plasma. The change was abrupt, not slow, as most people had envisioned. The heliosphere, which was conceived to gradually disappear into space, was instead found to have a clear, even wall-like boundary. The opposing magnetic field was more aligned with the heliospheric field than expected, hinting at some secret coherence in the cosmic landscape. Even more tantalizingly, Voyager 2 entered the boundary at a varying distance from Voyager 1, which showed that our solar bubble is not spherical but deformed, squashed and dented by interstellar medium pressures. Among these findings, both Voyagers carried something deeply human, the golden records. These were gold-coated phonograph records, to be able to survive billions of years, and intended as a time capsule for any clever life that might someday discover them. They were selected by a team headed by Carl Sagan, and they included Earth sounds, waves breaking, birdsong, laughter, music from Beethoven to Chuck Berry to ethnic songs from all over the world. They contained salutations in 55 languages, photos of human life and culture, and even a tape recording of brainwaves as Sagan's partner pondered love. It was the first time humanity had tried a message to the universe: this is us. This is our world. You are not alone. Voyager 1 is now over 24 billion kilometers away from Earth, and Voyager 2 is only a little behind. Their power sources are running low, and one by one, the instruments go dark to save power. But they still keep sending, and every weak signal detected by the Deep Space Network is a victory. These spacecraft are not machines, they are representatives of human curiosity and perseverance, representatives of our kind reaching farther than we can dream. And so we are back in the here and now, where Voyager 1, having been quiet for months, has resumed speaking to us. Its weak signal does not only bring with it scientific information, but also a testament to what humanity is capable of accomplishing when it is willing to dream big. And meanwhile, Voyager 2's findings beyond the heliosphere continue to challenge the known universe. The possibility that we might be cocooned inside a gigantic cosmic bubble, sheltered, or perhaps trapped, by forces that we still don't entirely grasp, is both exciting and unnerving. Are we shielded from the chaos of the galaxy, or are there those watching us from outside? The evidence remains open to question that scientists can argue about for centuries. Whatever the conclusions are ultimately reached, one thing is certain: the Voyagers have already altered history. They have introduced us to worlds we never knew existed, redone the textbooks on planetary science, and taken our message of life out into the stars. Far past when Earth's civilizations have altered or even ceased to be, Voyager 1 and Voyager 2 will keep moving through the galaxy, silent ambassadors of a small blue planet